Okay, we have one more set of problems we're going to look at here, and this is where x approaches infinity. We haven't seen anything like this yet, but it's not too bad when we do a table of values. So we're still going to do a table of values. So I'll call this guy my function. This is my f of x. My x is approaching infinity, so I have to kind of figure out what my table is going to look like there. So what kind of numbers are infinite? Those are big numbers. So I want x to be getting bigger and bigger. Notice there's not two sides of infinity. We can't like approach infinity from the left and right because infinity is kind of like our biggest thing we can think about. So we can just think about getting closer and closer to infinity. So we're going to plug in big numbers. I often start with 100, 1,000, 10,000. These numbers are getting closer to infinity. You can plug in 100,000 if you need to get more information. And then we plug our numbers into our function f of x. So let's go back to our calculator again. Our calculator comes in a lot of handy for these problems. So we'll plug in, our function is a messy one to type in here. So we get 8 plus x minus 4x squared. It's painful to watch me type this in, I'm sorry. Once again, don't forget your parentheses, x squared plus 2x plus 3. I hope you are trying these problems on your own before you watch my solutions and following along. And then we go to second graph. I type in my numbers. I'll type in my 100, my 1,000, and my 10,000. And then I can delete that last one if I want to just have it look nicer. So I look at what are these numbers doing as I move down the table. Those look like they're getting closer to -4. So I would say that the limit in this case is most likely -4. Okay, so that's how infinity works. Notice we don't have two sides of infinity. Okay, so go ahead and try that next problem. That one has x approaching -infinity. So we just have to make our x values negative instead of positive. Okay, so we said that this one was approaching -4. Once again, remember for your work, you need to write those numbers down from our table, from our calculator. I'm not going to because I'm kind of lazy right now. And it's a lot of writing to watch me do on Zoom. Okay, so for this one, this is my function. And so I have -infinity, so I need negative numbers. So I'm going to plug in -100, -1,000, and -10,000. Okay, you should do this in your calculator and see what happens. When I did this, I got 9e -5, which is 9 times 10 to the -5. This is a number with a bunch of zeros and a 9. I think I got the right number of zeros there. I'm trying to double check. And then this is 9e -7, 9e -9. Once again, you should write this as 9 times 10 to the -7 on your paper. Don't write calculator notation for me, write this notation. I'm just showing you what your calculator would get. So once again, this is a bunch of zeros. I'm not counting my zeros, so that might not be quite the correct number of zeros, but a bunch of zeros and a 9. These numbers are getting closer to 0. It's a bunch of zeros and then a 9, a bunch more zeros and a 9. So in this case, we would say that this limit is equal to 0. Okay, one more problem. For this problem, make sure your calculator is in radian mode. For calculus, we always use radians and not degrees. So once again, x is approaching -infinity, so we can use the same x values as we did in the previous problem. -100, -1,000, -10,000. Okay, and I'm actually going to put this one in my calculator so we can see what happens. This is x over sine of x. So let's look at this one together because this one's interesting. Okay, if you're not 100% sure if you are in radian mode, go to mode here. Make sure radian is highlighted. If it's not, then scroll over it and press enter. Okay, but I'm going to go back to my y equals. I'm going to have x over sine of x, close my parentheses, go to second table, and now I need to make these numbers negative. So -100, -1,000, -10,000. Those numbers are interesting, aren't they? We got some negative numbers, some positive numbers. Let's plug in -100,000, just plug in more to see what happens. Hey, looks like these numbers are bouncing back and forth between positive and negative numbers. These y values are not approaching one particular number. They're getting some positive, some negative. And so when we have this bouncing back and forth and not a clear final number, we say our limit does not exist, something we can talk about in class if that's confusing. If you look at the graph here, that graph is not super useful to think of, but what's happening here is there's a lot of bouncing back and forth happening. So we say that this last limit does not exist because we're not getting one concrete number that the y values are getting closer to. So that's just a fun one to add in the mix. We'll do a lot more examples in class.